This video, I thought we'd take a look at this book called The Book of Shaders, maybe to get some more basic understanding of how to do shader art. So there's a lot of stuff here. We basically don't need chapter 1 because we already have a way to run the shader through the shader editor. There's some stuff here. I looked a little bit at it. I think maybe the shapes chapter will be interesting. All right. So let's try to get started. So I'm gonna read a bit, and then I'll read off screen, and then I'll come back and we'll kind of talk about what's interesting. All right, the first thing is just drawing a square. So in the interest of being good students, let's do that. Let's call this shader book 7 because we're in chapter 7. And here we have our little starting shader. And the goal is to draw a square. All right, so they have this ST. We have our position, which goes from -1 to 1. They want something that goes from 0 to 1, so we can remap our position like this. Then they define a color, and then they have this step function. So it has a, let's call it step place, and then they have a value, and basically it's if value is greater than or equal to step place, then you return 1, otherwise you return 0. And then they have something like this, p.x, and the bottom is the y, and the color, they say left times bottom, and then they just assign that here. And let's see how that looks. So we just have this white square here, as you can see. If I remove this, it says everything's black, and then we get a white square. I actually think maybe this is better. I just like it inverted. And obviously, maybe they want us to do something like this. I think we can do. Actually, should be like that. Now it only takes up the center. So that's this is a pretty simple shape. We can know where the edges are by these simple if statements, basically. So that's one way to build shapes. An interesting thing we can do is we can define a rotation matrix. And basically, if we want to rotate through an angle, theta, let's say it's 30 degrees, 180, like that. That's 30 degrees, and we convert to radians like that. Then it's something like this, minus sine theta. Sine theta. This is just something you can look up if you like Google rotation matrix. So we have that, and then we can say, okay, actually rotate it by 30 degrees. And you can see it rotated a bit. Problem is it rotates about the upper left corner, or maybe the lower left, which is not what we want. We actually want to rotate it about the center of the screen. So what we can do is, I think we can do like this. So 0.5 plus. Yeah, now you can see it's kind of rotated by the center. Another way we can do it is we can rotate the original coordinates. So we have to do this 0.5 thing because of the fact that the coordinates go from 0 to 1. But we can also just rotate the original position and then add 1 to that and divide by 2. That should be the same. It's pretty much the same. And then we can have different rotations like that. So all the other method is the same. We just kind of rotated the coordinates before we did anything. Rotate by 90 degrees. It should be exactly the same. So it's a square and like that. All right. Let's continue a little bit with the book. Okay, funnily enough, step is actually a built-in function, which I didn't realize, but there it is. You can just not do that. And then we can actually say, apparently left, we can say step P, or let's say, you know, lower and upper. And then here it would be lower x times lower y times upper x times upper y. Maybe there's an easier way to do that. And then this also has to be a vector, fair enough. Then that works. You can change this a little bit if you want a different size, but we don't want to do that right now. All right, another built-in function that they mentioned is this smooth step. So now you give it 2 parameters. Let's actually go ahead and remove the rotation, just it's a bit easier to see what's happening. Now we get this weird behavior. Which I'm not sure how to understand. Let's try something else. Let's say color is just vec3 smooth step p of x, sure, between 0.5 and 1. So to me it looks like it goes from 1 and then directly to 0. If you do that, I'm not sure how to understand this because p of x is supposed to go from 0 to 1. Somehow it's 0 after this point. What if we do like that? All right, I think the problem is that I switched the order of the arguments. So if we do like that, that makes a lot more sense. So we start with 0 when you're below 0.5, and then between 0.5 and 0.6, you rise slowly to 1. So we can kind of have this intermediate region. And it also works on vectors. It's supposed to anyway. And this one. All right. So they have this little exercise, like do another implementation that uses floor. I think that could be somewhat interesting. And we can maybe change the lower one to be like floor of p times 2 divided by 2. That did not make any sense to me. So if we multiply by 2, then from 0 to 1/2, the answer will be 0. From 1/2 to 1, the answer will be 1, and beyond that, then there's no more beyond that. So it should split it into 2. You can even try to see that like this. Color. Let's just do this. Px, I mean. Yes, exactly. So it's 0 first and then 1. And can we, if we just multiply by 4, we will kind of split it up like that. Then, what do I want? What if we do like modulus of 1? Okay, that didn't work. So like mod f, maybe. Is it f mod? Is it f mod f? Is it f? Just mod. That didn't work. Okay, I kind of wanted it to repeat itself. Maybe we do mod and then 2. Right, so this is what I wanted. So we can get it to repeat some number of times. What do I do? 3. If I do 3, so this, like every second one, it will repeat itself. And this is how many we get. So here, every third one, it will reset. Not really repeat, it's more like reset. So you can get this pattern where you reset. That's very interesting. And basically this has this effect. No, you need the floor as well. And it's not really resetting, it's just the way it's plotted that makes us think it's resetting, because really it's increasing all the way to 3 and then going back down to 0. Yeah. All right. So you can play with this. I guess we could try to do something like floor mod py 5, or if we do 2.5 like that, and then we need another number. And I have 3 multiplication. Now we can make something like this. It looks horrible, but let's do, maybe let's do red and blue. Still a little bit horrible. How about we do this? This will be blue. This will be red. And then we basically want like red, but if they are both 1, don't do anything. The same here. And what did I do wrong? Okay, so we can make this kind of pattern now. Interesting. And we can go up and rotate it. All right. It's not really a square anymore, but whatever. It's not really the point to learn how to do a square. Let's continue with the book. Okay, another kind of interesting exercise is make a function that draws the outline of a rectangle. Let's see if we can do that. Let's see if we can do that. So we're back to black. Now, what should be like the thickness of the rectangle? Outline. Let's make it 5% of the screen. And then we want to do something like, let's call it brightness. And if the brightness is, let's say if the position X minus where let's say the left edge, which we can put like 10% of the screen, if that is less than the thickness, right? So basically, I guess we want a step function. And if this value is below the thickness, and maybe we then want actually the absolute value, so it's more like the distance. So it doesn't matter if you're less than that or greater than that. Then let's try to use that as the brightness. Right, and then we have the rotation again. Get rid of that. So see, it's pretty thick. Let's do that. A little bit more thin. All right, but now we need to combine it with the other sides. So really, let's do like that and like that. Now to give us how are we going to do this? Now we have two brightnesses. Actually, we can do it like that. Let's plot them like this. So you can see here they are kind of like they represent two different edges. Now, the interesting thing is before we were kind of multiplying the edges together. So it doesn't really work here because the point where they intersect is only like that little corner. Right, so what we need is we actually need something that takes care of the edges. So we need something like this. Yeah, let's say lower it's P and the position. Now we kind of want the position. So we want something like that. Let's get rid of this one for now. And we want to say, yeah, either of them is good. We get something like that. However, we also have to be above the like lower edge. And that did not work. So we need to be above both the X and the Y. So that gave us something like that. And maybe here we also need to say like minus the thickness. And right. So why is that? Maybe we need to say 1 minus that. Because the step function because the step function is like this, right? So the first argument is where you go from black to white, and this is like the control value. So that's why we need to flip them. Anyway, we can get the upper edge, and that should be whenever we are above this value. And we need to say like 2. That's the upper edge. So this should be 1 when we are outside. So actually we want to do it like that. And now if I multiply by this, we should cut off a little bit more. So let's make yet another edge. I'm kind of thinking we can even do some magic here. So let's say xy, xy, and then the thickness is just a vector 4. Here we do brightness Z plus brightness W. It's probably not going to work because, yeah, it's just going to repeat it. So let me actually do it a different way. So these are the lower edges. Let's make the upper edges, just call them upper brightness. So it's actually going to be P minus 0.9 because that's where we want the upper edge. And thickness like that. And then we simply have plus that stuff. And there we get an outline, and we can control the size of the outline like that. So somewhat complicated perhaps. Yeah, but there you have it. All right, next up is making some kind of circular pattern. So we're gonna go and get rid of all this. And we can simply say vec3 color is vec3 distance of P. So pos. So remember pos goes from -1 to 1. So this is a number that will be 0 in the center of the screen. Actually, it's probably has to be length. Actually, let's go with distance. And what is the distance we're interested in? It's the distance from, for now, 0, 0. So this will be 0 in the center of the screen, and it will go towards 1 on the edge. So we should see black in the center and then going towards bright white in the sides. So here we have that. And this thing we can take out, and we can say brightness is this, right? Brightness. But we can even try to do some things here, like let's try this. So this should make it darker, like the dark area should extend further out. Well, there's still just the central region, like outside is still pretty dark, but we can change that if we like divide it by a little bit, then it should reach even further. We can do like divide it by 2. We get something like that. So this is a way we can control it. And we can even say, let's say brightness is now the step, and whenever the distance is greater than 1/2, then set the brightness to 1. So we get something like this. And what if we messed around with, so yeah, maybe we should try that first. We can move the circle around like this. Just changing what we calculate the distance to. We can also try to distort the coordinates. I'm not sure exactly what I want to do, but let's say something like P of x is equal to or plus equal to sine of P of y times some number. Maybe also divided by number. So this means that as we increase y, the x coordinate will like wobble a little bit. And I think that should affect, so now you get this kind of weird shape. And if we make this one very small, it basically doesn't affect anything. And let's make it just not as strong, but let's make it oscillate much faster. And maybe even 10. So you can kind of make this weird shape by manipulating the coordinates. So basically sine is like a wave, right? So what I'm doing is each point on the circle is shifted to the right or left with this wave. And the wave varies as you go up and down because I have py here. if you do px, I'm not sure it's going to show anything interesting. Okay, kind of does. It's like a Batman shape. I don't know what to think about that. We can also try what happens if we change this with some kind of thing. Get another interesting shape. All right, let's keep reading. They have an exercise about adding some animations to this thing. So why don't we do that? I do want to just like reduce it a little bit. The brightness. Maybe, I mean, we can just say divided by 2 and it'll be like kind of gray outside. It's a little bit boring. What if we did like 1 minus brightness in the red channel, brightness. What would that look like? Get this shape still like it's just too bright. And no, it's not good. It's not good. What if we do divide by 2 here? Divide by 4. Okay, basically I'm just trying random things. I think let's just keep it simple. Let's just keep the brightness. Right, but we can add some animations. What if we said we had our own time, which is maybe like sine of time, something like this, and then we add that here. Now we can add some cool animations. Maybe I don't really want this. Maybe I just want time more like 5. So that's kind of a constant rate of change. And it does have this ugly thing where it snaps back every once in a while. Which I'm not really inclined to change right now. So let's just do it like this. And what else can we do? I guess we can say p.x plus time. Just have it moving away. Goodbye. Right. Not sure that's so interesting. We have this distance. What if we add some modification here, like a tan px? Does that do? Nothing super interesting. I can add that out here. Okay, now I'm just messing around with random functions. Oh, this is kind of cool. It almost looks like fire. And now we can try to change this. Kind of weird fire. 15 maybe. Right. Let's not get stuck in this rabbit hole. Still like that. All right, let's keep reading. All right, this one is interesting. So let's make a new sketchpad. So they remap the space to go from -1 to 1. We already have that. But then they have some kind of distance. So we'll say like that should be the equivalent in our code. And then the color is simply, well, let's make our own variable brightness, which is then the fractional part of d times 10. So we have something that repeats a lot. Put brightness in here. And let's see how that turns out. So it looks like this. What if we have one here? So the absolute makes it so that each of these 4 regions are the same, because here x and y are positive, here y is negative, here x and y are negative, here only x is negative, y is positive. But because of this abs, then they are all the same. If we delete that, we should only see 1 quadrant, and then we have this times 10. So the 10 is changing. So the d is just the distance from this point. We can also write it like this, and then we can kind of move both around. So we can move the point over here if we want. And then obviously, like, the distance is increasing the further we get away. But if we take the fractional part, then whenever we get above 1, we snap down to 0. So that's why we see it going back to black. And how can we increase the length of those? Maybe what happens if we do this? Yeah, so basically this number controls how wide those individual things are. So we can create a pattern like that. What happens if we put back in the apps? Just get this. All right. Okay, so now we get to something kind of interesting, pretty interesting. Polar shapes. So basically we can calculate the distance to the center of the screen like this. And we can calculate the angle that we're at just by this function call. And then we can do things like, let's color by the angle. Yeah, let's try that just to see how it looks. So you can see it starts at 0. Well, it's a negative here, I guess. So it's negative, it becomes 0, and then over here it becomes 1. So for that reason, maybe we want to say plus. No, actually, how are we gonna do that? Yeah, I want to say something like if a is less than 0, then just say a plus pi, 6, 535. Which is also not quite correct. Actually, it should be probably 2 times. Like that. So now we have it's from 0 here. I kind of like that, from 0 here all the way to 2 pi. And then we can say things like, actually, let me do like this. And for some reason it doesn't do anything, because we need this. All right, now we got to go from 0 all the way to 1. We get this kind of course shape. But anyway, that's not what we were supposed to code. Let's just get rid of that. And they have something they call if. What is if? Let's try to create something we call brightness again. And for a second, let's just make the brightness equal to A again. Now the problem is, it's not very interesting. So what we can do is we can say cosine but plus 1 and divided by 2. We get something like this. So let's make it sine instead, because sine starts at supposed to start at 0 over here. Let's do that. So it's negative down there. Fair enough. Right, so sine is like -1 here, and then it goes towards 1 up there. And cosine is just the same, rotated by 90 degrees. So we have this thing. Then we can multiply by some number. If we wanted to repeat 3 times, we can do that. And then we can basically say, so now we have a number that kind of is large here and small here. What if we use that to change the radius? So we can say we have some base radius and we multiply it by 1 minus that. So that would mean that in these regions it's basically not affected, and here it's basically 0. Okay, so what is the radius? Maybe the radius is just 1/2. And then we have something like this. So maybe we want to say, okay, if it's larger than 0.1, then it's equal to 1. So we get this, which is not really what I wanted. So let's go back to this. So how do they do it? Maybe let's just look at that. So they also have this times 3, and then they have a smooth step. All right, let's try that. So the brightness is going to be 1 minus smooth step of this thing. Maybe we also call it F. And let's just use sine. Didn't really do anything. Is my radius too bad? My radius is not there. My radius is the problem. So that should actually just be D. All right. So I think using a fixed number was a big problem. What happens if we just do this? Nah. So the smooth step is kind of important. We have this thing that varies. It goes in and out. Can we actually see where that is? So we can do something like 0.1 plus f. That should tell us, maybe apps of f. That should tell us where it is. Okay, so yeah, because it's just based on the angle, so it's like everywhere. Okay, great. So that means when we approach these points, we should get something that is close to 0. And I guess it kind of corresponds to these guys. Fantastic. And then we have a step change at the radius where we are basically equal to this. So we can also, I'm not sure what the effect of the smooth step is. We can also do this. And it's the same basically. This one's just a little bit smoother. And we could change this to be a large number to get something like that. And of course, if we change this, we get some more weird shapes. And don't do that, that's weird. Right, and now there's like this example of a triangle. Should we try to see if we can make a triangle ourselves? So we're gonna need the angle and stuff. Again, let's start by doing this. And can we just do like floor of A? Looks like that, but let's do it like this. Right. So now it goes from 0 to 1 all the way around. Let's multiply by 3, get something like that. And then we can take the fractional part. And that doesn't work, of course, because it's the floor function. So what if we just take the fractional part like this? We get these 3 regions. That's interesting. What we can do is maybe, let's say, I want to rotate it by like 1/3 of a fourth. Actually, I think I wanted to do that. So now we have something like this. Pretty sure we're not going to get a real triangle, but I mean, we're already close to triangle shape. So here we can say, okay, what if do this? Of course, we get full brightness. So what do I actually want to do with this? I am not sure. But we can say this thing. Kind of looks cool, honestly. It's not what I wanted to make, but it kind of looks cool. All right, but do I want to do? The thing is, we kind of want, how do you make a line here instead of this circle? Actually, don't know. Just gonna try something random for, there's no X and Y of that one, of course. Okay, let's actually see, because I cannot figure this out myself. All right. So we have that. They are also adding pi. So we just add pi as well. Then they have some other number, which we're going to call AR. So they have 2 pi divided by 3, because they want a triangle. And then they have their brightness. I think it's going to be cosine of the floor 1/2 times A divided by what we call D. Oh, sorry. Their R is AR. And it's multiplied by D. So it's definitely not that, because that's completely wrong. Right, so actually they want this mapping. Ah, no, they don't. Great stuff. Remap from -1 to 1, so we got that. Number of sides. Don't know why they swapped that. So maybe we get rid of this. Then they have this R thingy, which maybe we'll just call it R, which is 2 pi divided by 3. Then they have, there's also smooth step, right? Fair enough, fair enough. But they have cosine floor 1/2. And this is supposed to be a plus. Finally, brightness is 1 minus smooth step. So like a very short edge, and we get a circle. Fantastic. Absolutely fantastic. The floor is inside that. Okay, I think I made a typo. It should be brightness here. Now we get a triangle. Great, great, great. And then we can just change the angle a little bit. Like that. Maybe. Like that. Ta-da. I think we're gonna call it here. I'm a little bit tired, so I will see you in the next video. Bye bye.